Jai Hind to all of you. I am Dr. Gaurav Saxena, Associate Professor in the Department of Electronics and Communication Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. So today I have discussed the electromagnetic field theory having a code of BEEE 301, and today I have discussed the points, coordinate system and transformation. So whole of the unit is to be divided into the two parts. First one is the internal marks and the external marks. The external marks is 70 and the internal marks is 30, which is given by the uh, college, and it is further divided into the two parts, and 20 marks is to be based on the CT and 10 marks is to be the assignment and the attendance, and the external marks is to be given in the 70 marks. So the credit is 3 of this, and this is the unit 1. Unit 1 is coordinate system and transformation. This is first unit is prescribed in that of basics of vectors and the vector calculus. So in the basic of vectors, addition, subtraction and the multiplication of the vectors in the Cartesian, cylindrical and the spherical transformation, which are given in the basics of vectors, and the in the vector calculus, the differential length, differential area, differential volume and del operators, gradient, divergence of a vector, divergence theorem, curl of a vector, Stokes theorem and the Laplacian of the scalar vectors which to be given in that particular unit. So I discuss it here, and the unit 2, unit 3 and the unit 4 and unit 5 which are later I have to be discussed here, and the textbook which is given in that particular to whole of the syllabus which have to be covered in that books. So first one is the textbook. Textbook is Matthew Anusadiku. The name is Elements of Electromagnetics, Oxford University Press, and the reference book William Hay and Buck, Engineering Electromagnetics, and the name is that's, and the McGraw-Hill Education. So this is what is electromagnetic wave. So first we discuss what is the application of electromagnetic wave and what is the meaning of electromagnetic wave. So electromagnetic wave, according to the IEEE definitions, the electric field and the magnetic field and the direction of propagation which are perpendicular to each other. So we can say that wave is called a electromagnetic wave. So in this field, so we can see that this is electric field vector, red one portion is electric field vector and the blue portion is magnetic field vector, and the direction of propagation which are perpendicular to each other. So we can say that is EM wave. So what is the application of EM waves? EM waves application in microwave, antenna, electrical machines, satellite communication, radar communication and the fiber optics which are belonging to this. So many application in that field. So I just started. So whole of the EMFT, electromagnetic field theory, is governed in that particular Maxwell equations. 4 Maxwell equation is here. So I discuss in after sometimes. So first unit which have to be I have to be started. The first one is the what is the scalars and the what is the vector. So scalar quantity at that quantity which having only a magnitude, just like a time. So I just given that. So today the time at that at right time is 12:34. So we can say no direction is to be here. So 12:34 is a scalar quantity, and distance also a scalar quantity, and the temperature also a scalar quantity, and the mass and the pressure also a scalar quantities, because they do not define in the directions. So we can say this is a scalar quantity and the vector quantity that have both magnitude and the directions. So we can say that quantity is called a vector quantity. So just like a velocity, velocity also a vector quantity, because which to represent the velocity we also require the what is the magnitude of that particular velocity and the what is the direction of that particular velocity, and the force also a very known, we can say that that is also a vector quantity, and the displacement also a vector quantity, and the electric field intensity, magnetic field intensity also very, this is very known vector quantities which are discussed in that particular stream. So first we say what is the meaning of unit vectors. Unit vector is defined. What is the meaning of unit vector? So first we, whole of the electromagnetic field is governed in the vector as well as the scalar quantity. So unit vector is defined where your vector is going on. So that means if your vector A is defined, So in what direction this vector A is defined? So we represent this unit vector A. So A is defined the vector A upon A ka mod. So the value of this unity vector is 1, and the vector A is defined vector A ka mod and direction of that particular vector in the A direction. So we can say this is a unit vector. So unit vector is this. A is a unit vector. How we solve this? The magnitude of that particular unit vector is 1. So such example in a Cartesian coordinate system or rectangular coordinate system I have just taken, if vector A is defined ax comma ay comma az, where capital Ax, Ay and Az are the magnitude of that particular vector. So total vector in Cartesian coordinate system is defined as A is equal to Ax plus Ay and the Az, where capital Ax, capital Ay and capital Az, which are the components of A, or we can say the magnitude of vector A in the direction of Ax vector, Ay vector and Az vector. So Ax is the unit vector in the direction of x. Suppose we draw this Cartesian coordinate system in the x direction, y direction and the z direction. So in x direction the unit vector we have to be planned that this is Ax unit vector, and here in the y direction Ay is the unit vector, in the z direction Az is the unit vector. So whole of the vector A is defined the magnitude in the x direction. Suppose we have taken the this unit 3, so 3 into Ax plus, if we suppose we have taken this 4 unit in the y direction, so 4 into Ay, and the z direction we have taken to 5 unit in the z direction. So vector A represent the 5 into Az. So vector A is defined magnitude of that particular direction and particular unit vector in that direction. So in x direction we have taken the 3 units, so the vector A defined 3 into Ax plus 4 into Ay, because we have taken the 4 unit in the y direction. So the magnitude in the y direction is 4 and the z direction is 5 units. So whole of the vector A is defined, which is equal to 3Ax plus 4Ay plus 5Az. So this is the representation of a vector A in Cartesian coordinate system. So how we calculate the magnitude of vector A? If the vector A is defined Ax into Ax plus Ay into Ay and Az into Az. So vector A, the magnitude of vector A is how we calculate? So under root of what is the component of magnitude of in x direction, which is Ax. So Ax ka whole square plus Ay ka whole square plus Az ka whole square, and the unit vector in the direction of A is defined vector A upon mod of vector A. So vector A is also we have to be taken by Ax plus Ay plus Az, and how we calculate the vector A mod, which is given by the formula under root Ax square plus Ay square plus Az square. So we have to calculate the unit vector AA in the direction of A. So second point is how we add the two vector quantities or three vector quantities, or subtract the two vector or three vector quantities. So by using this, so two laws or two rules we have to be taken if we add the two vectors. First one is the parallelogram rules and the second one the head to tail rules. Suppose two vectors where vector A is defined Ax, Ay, Az, this is the magnitude of that particular vector in the direction of x, y and z, and the vector B is defined Bx, By, Bz, having the magnitude in that particular direction x, y and z, which one is bx, by, bz. If we add these two vectors, c is equal to, c is the resultant of that vector and vector a and vector b, if we want to vector to add it, so by using the parallelogram technique or parallelogram rule, so if this vector is represent the vector b in this direction and vector a suppose are giving in this direction, so the resultant is the diagonal of that parallelogram, which is c is equal to a plus b. So by using the parallelogram technique, we have to calculate the what is the resultant of that particular two vectors. So and the second one we have to also be taken, if the vector a is here and vector v is here, the direction of this from here to here and here to here, if resultant is here vector c, so vector c is defined vector a plus vector v, which is equal to the vector c, or we can say vector a plus vector b minus vector c is equal to 0, or that means the vector c is the resultant, which is equal to the vector a plus vector b. So we follow the both the rules, parallelogram rule and head to head rules in EMFT. So vector addition we have to be taken in previous slides, but the vector subtraction we also governed by the parallelogram rule and the head to tail rule. So in that direction, if vector a is defined here and vector b is defined here, so the vector of minus b is the opposite of that particular vector which is defined by the minus vector b. So what is the resultant of that two vector is vector d, which is defined here according to the law of parallelogram. So this is also a vector a and this is also a vector b minus b. So by using the parallelogram technique, vector d is equal to vector a minus vector b, and by using the head to tail rules, if this is vector b, so if we design a vector minus b, so vector minus b's direction is here and vector a is here and vector d is here. So by using the head to tail rules, so the resultant vector d, which is equal to vector minus b plus vector a, vector minus b plus vector a. So the resultant is vector d is equal to vector a minus vector b. So by using the head to tail rules and the parallelogram rules, we easily add the two vectors and subtract the two vectors. So laws of algebra also follow in the addition and the multiplication of the two vectors. So first law is commutative law. So according to the commutative law, if the two vectors are sums, vector a plus vector b, so we also, which is equal to the vector b plus vector a. That means that if we add two vectors, vector a and vector b are two vectors, if we add vector b in vector a or vector a in vector b, which are same, so all the vectors follow the addition commutative law. So commutative law explains that a plus b is equal to a plus b. So we have to be prove that if vector a is defined 3ax plus 4ay plus 2az and vector b is defined 4ax plus ay minus az. So in LHS side, vector a plus vector b, which is equal to 7 into ax plus 5 into ay and plus 2 or minus 1 plus az. So the LHS side, we have to be receive these two vectors sum a plus b, 7ax plus 5ay plus az. But in the RHS side, if we taking the b plus a, so vector b is 4 and vector a is 3. So same answer is to be occurs. So by using these explanation, we easily say that the laws of algebra in the vector quantities obey the commutative law, and as it is associative law is a plus b plus c, a plus b plus c. Yani if we add two vector in the post calculation and if we add two vector in pre calculation and we add the another vector, the answer should be same. And the distributive law states that if we multiply a k vector or k scalar quantity in a plus b, so the value of this scalar quantity into the two parts ka and kb. So this also follow the distributive property in the additions. So this is the very important parameters ki the two vectors in the addition form obey the commutative law, add the associative law and the distributive law. In the multiplication form, pre and post multiplication of the scalar quantity which are same, that means Ka is equal to Ak. If we multiply the any scalar quantity to the vector quantity in the pre and post which are same. So and the associative law which also same, if we apply a K L into A. So if I can say vector A defined by 3ax plus 4ay plus 2az, if L is equal to in a scalar quantity which is 2 and K is also I am saying 3, so the total K into L into A, which one is 2 into vector A, that means this one is 6a. So in this case the LHS side is 6a. If we take in our RHS side, so what is the value of K? K is 3 and L is 2, that means into A, which one is 6 into A, so which are same. So by using the multiplication laws of algebra, so the associative law also follow in the multiplication theorem. So third slide is position and distance vector. What is the meaning of the position vector and the distance vector? So position vector always defined according to the origin. That means that if I can say some point 3, 4, 5 having a point P are given, so this is a position vector. What is the meaning of position vector? This 3, 4, 5 vector is defined at the origin. Origin, that means 0, 0, 0. That means in the x direction this is 3 and the y direction is 4 and z direction is unit is 5. So always position vectors is measured according to the with respect to the origin. Origin is defined at 0, 0, 0 and the distance vector is defined two position vectors. That means if I can say some another, we have to be taking a position vector which are with q defined as q having a coordinate system 4, 5, 6. So this is also this is q, the vector is, the value of this is q. So this one is 4. What is the meaning of vector p? Vector p is defined 3ax plus 4ay plus 5az, and vector q is defined 4ax plus 5ay plus 6az. So this is defined by the position vector because the value of 3, 4, 5 from, if we take in the 3, 4, 5 from the origin. But the distance vector, what is the meaning of distance vector? Distance vector PQ is defined the vector Q minus vector P. So two position vectors distance is measured in terms of the distance vector. So if we want a distance between the P and Q, so easily we have to calculate it by the formula under root x2 minus x1 का whole square plus y2 minus y1 का whole square plus z2 minus z2 का whole square. In this case, what is the meaning of this pq distance vector? Vector q minus vector p. That means the what is the meaning of this? 4 minus 3 का whole square plus 5 minus 4 का whole square plus 6 minus 5 का whole square in that particular direction. So distance vectors, I already explained to you what is the meaning of this, the separation between the two point vector. So RPQ is equal to RQ minus final minus initial. So easily we have to be calculate the distance vector by using the point vector. So this is some example according to the what is the component of A in AY, what is the unit vector and what is the magnitude of this. So some laws of algebra which are dependent upon this example. So vector A is defined 10ax minus 4ay plus 6az and the vector V is defined 2ax plus ay. So what is the component of A along ay? So we see that what is the meaning of vector A? Vector A is 10ax minus 4ay plus 6az, the component of A. So component of A along ay which is minus 4. So component of A along ay direction is minus 4. So because minus 4 is defined along ay. The magnitude of 3a minus b. So we know that k into a, vector A is equal to a into k. So here k is equal to 3. So easily you have to just multiply a vector by 3. So 3a is equal to, what is the value of 3a? You easily calculate. So by using the 3a, 3 into 10 into 4 minus 4 into 6 minus b, b is the vector where 2 comma 1 comma 0. So easily we have to calculate the what is the value of 3 into a minus b, which one is 28ax minus 13 into ay plus 18 into az. And what is the magnitude of this? The magnitude we have to be calculated by the formula under root ax square plus ay square plus az square, which is 28 का whole square plus minus 13 का square plus 18 का square, which one is under root 1277. The value of this is 35.74. And third one is what is the A unit vector along A plus 2B. So suppose the A plus 2B, suppose C is the vector which is equal to A plus 2B. So what is the value of A plus 2B? So easily we have to calculate this, a plus 2 into b, which one is 14ax minus 2 into ay plus 6 into az. So what we find? A unit vector along a plus 2b. So what is the unit vector? Along C, which is equal to vector C upon mod of vector C. So what is the vector C? Vector C is 14 minus 2 comma 6. And the mod of C is under root 14 का square plus minus 2 का square plus 6 का square. So according to them, the unit vector along C, or we can say unit vector along A plus 2B is 0.9113 AX minus के 0.1302 AY and 0.3906 AZ. Okay. Another example I have taken by position vector and the distance vector, example 1.2, which is very important. This question is to be asked in AKTU. So what is the point P and point Q are located at 0, 2, 4 and minus 3, 1, 5. So we calculate the what is the position vector RP. So what is the meaning of this? If I can say, we draw a Cartesian coordinate system. This is direction x, this is direction y, and this is direction z. The unit vector in x direction, suppose which one is ax, in y direction ay, and z direction is az. So what is the point P in the direction of RP. So how we calculate it? So RP is 0 into AX, 0 into AX. So we calculate 0 into AX plus 2 into AY plus 4 into AZ. So what is the value of RP? So that means you just calculate the what is the RP, 0 into AX, the coordinate of this P is 0, 2, 4. So we easily calculate the vector of P. What is the vector of P or RP? 0 into AX plus 2 into AY plus 4 into AZ. So that means that the RP position vector is 2AY plus 4AZ. So this one is 2AY plus 4AZ. And the distance vector P2Q and another vector position vector is defined, Q is minus 3. Suppose Q vector is defined here minus 3 comma 1 comma 5, whose vector. So we can say the position vector RQ is defined minus 3 into AX plus AY plus के 5AZ. So the position vector is defined, Q is minus 3AX plus AY plus 5AZ. So we calculate the distance vector P2Q. So what is the meaning of this? So P2Q, that means the what is the RPQ. So RPQ is the RQ minus R. So we easily calculate the what is the value of distance vector P2Q. So RQ minus 3AX minus 0x. So what is the value of this? Minus 3AX. Then AY minus 2AY, that means the minus ka AY, and the Z is 5 minus 4AZ, that means the plus k AZ. So the distance vector is defined by the minus 3AX minus k AY minus plus k AZ. So this also we have to be calculate by minus ka 3AX minus ka AY plus k AZ. Or we can say the distance vector is given by the minus 3 comma minus 1 comma plus. So easily we have to be calculated. And distance between P and P2Q. So that means that distance is a scalar quantity. So we easily calculate the distance between P2Q is defined by the what is the mod of this. So the mod of this is minus 3 ka whole square plus minus 1 ka whole square plus 1 ka whole square. This one is 9 plus 1 under root 11. So under root 11 is defined 3.317. So easily we have to be calculate the what is the distance. Distance means that means the you modify what is the meaning of distance. That means the distance vector magnitude, because distance is a scalar quantity. So what is the meaning of the distance is a mod of the distance vector. And the second last question is that a vector parallel to PQ with magnitude of 10. So find a vector parallel to PQ with magnitude of 10. So what is the value of this? The magnitude of, so vector A is defined that magnitude of that particular direction, the magnitude of vector A and direction of AA, that means the unit vector in that particular direction. So but the magnitude of A is 10, that means the unit vector we have to be calculated, the unit vector of this distance vector we have to be calculate by using the formula RPQ upon RPQ ka mod. So mod of RPQ we also calculated 3.317, and the RPQ vector is defined by the minus 3AX minus AY plus AZ. So the value of unit vector A along the PQ line, so which one is this? So that means the vector A parallel to the PQ line having a magnitude of 10 is given by magnitude into unit vector in that direction, unit vector in that direction. So magnitude also given in that particular question, which one is tan, and the unit vector in that direction a, which is defined by this -3, that means -3ax minus ay plus az, and the mod of this is, which one is 3.317. So easily we have to calculate what is the vector a having a magnitude of 10 and the direction is parallel to the this vector pq. So you solve it and the value of this is -9.045 ax minus के 3.015 ay plus के 3.015 az. So easily we have to calculate this question. So this is example 1.2 completed, and the third topic is vector multiplication. So vector multiplication is divided into the two parts, scalar product and the vector product. So if vector a and vector b is defined in a particular direction, then the dot product, what is the dot product? A dot b, and what is the cross product is a cross b. So dot product always planning to a two vector quantity and giving a scalar quantity. That means the अगर आप किसी दो वेक्टर को मल्टीप्लाई करेंगे, डॉट प्रोडक्ट करेंगे, दैट मीन्स तो वो किसी दो वेक्टर का जो मल्टीप्लिकेशन होगा वो क्या आएगा? स्केलर क्वांटिटी आएगा. दैट मीन्स ऑलवेज स्केलर प्रोडक्ट एंड वेक्टर प्रोडक्ट both are defined for a vector quantity, but after the dot product it's give a scalar quantity, and the cross product gives the vector quantity. And the same as three vectors a b c. So the scalar triple product a dot b cross c. So the b cross c is giving a vector quantity. This is also a vector quantity. So vector dot vector which give a scalar quantity. And in the vector triple product, they also given a vector quantity, and vector a also a vector quantity, and vector a cross vector b which also give a vector quantity. So always scalar triple product give a scalar and vector triple product gives a vector quantity. So you remember that these terms, what is the meaning of scalar product and what is the meaning of the vector product. So first dot product we have to be defined the product of the magnitude of the a and b and the cosine of that particular angle between them, which has to be defined by the dot product. That means if two vectors a and b are defined, then the dot product of them, which one is vector a mod, vector b mod, and cos theta ab. So easily we have to be defined here. If vector a is defined here and vector b is defined here and the angle between them is theta ab, so what is the meaning of this? A dot b is equal to a mod vector a mod, and if we calculate a dot b, so vector a mod, vector b mod, and the cos theta of ab, which is equal to the a dot b. So if a is defined ax, ay, az, and b is defined bx, by, bz, so ax, ay, az, and the bx, by, bz are the magnitude of that particular vector, then a dot b is equal to ax into bx, ay into by plus az into bz. So a and b are orthogonal. If two vectors, if we prove that, if I can say vector a is defined here and vector b is defined another vector, so you have to prove that two vectors are perpendicular or orthogonal to each other. So we can say vector a dot vector b, the dot product of that particular two vectors should be 0. Why? If two vectors are same, orthogonal to each other, A dot B, that means vector A mod, vector B mod, and the cos of theta AB, which is 90 degree. So that this means vector A mod and vector B mod, and the cos 90 should be 0, so the value of 0. That means if two vectors are orthogonal or perpendicular to each other, then we easily prove that the two vectors are orthogonal in each other by using the dot product. So the dot product of that particular two vectors are 0, that then we conclude that vector A and vector B are perpendicular to each other. Thank you to all of you. Next, cross product and dot products we have to discuss in next slides, which are recording to earlier. Thank you.